This video is a review video for Learning Targets 2.1 and 2.2, which covers structure of solids, crystalline and amorphous. Let's go ahead and get started. Types of solids that we have talked about are amorphous and crystalline. Crystalline solids are made up of particles that form repeating patterns. And as you may remember from class, this word patterns is very, very important. As you can see with the diagram, that there is a pattern that emerges within the particle structure. So the pattern is not in the matter itself or in the substance, but really it's in the particles that make it. So if we were to be able to see the chlorine and the sodium atoms, we would see that there's one every other, up and down. This is a repeating pattern. This is an example of a crystal. You can see that it has flat edges, and we'll talk about in just a second why that's so important. But that is a characteristic of crystals. We also have a diamond as an example. Properties. They are strong, less flexible, high melting temperature, and more conductive. Let's talk about why these are. Number one, strong. There's not a lot of space here in between the atoms. That's why we get this very strong structure. In addition to strong, they are less flexible. We could also think of them as being brittle. They are brittle because they break along straight lines. So if I try to flex this object along this line, the whole line will break off. And that is why they are not flexible or less flexible. They have higher melting temperatures and they're more conductive. The conductivity, or the ability for heat or electricity to move through them, has to do with the alignment of the particles, just like all of the other properties do. If we look here, we see that there's a straight line through the substance from one atom to the next to the next. So heat or electricity could move straight through in these two directions. Whereas with an amorphous, it doesn't have a straight path through. So that is where those properties come from. Let's go ahead and take a look at amorphous. Amorphous solids have particles that are not in a regular pattern. If we take a look at these, we will see that there's a lot of disorder. They're not aligned, and there is not a pattern. That's the most important thing to remember. Plastics, butter, these are examples. Some properties of these are they are more flexible and less heat conductive, as you can see down here at the bottom. If we're to take a look at this diagram, we see that they're less heat conductive because if heat is trying to pass from this side that way over to this side, we can see that the path through the substance may not be a straight one, and therefore heat will not move as fast. And that is what conductive means. So less heat conductive, and also not as electrical conductive. They do not conduct electricity very well. If we take a look at these two diagrams together, we're able to look at the properties in a little bit more detail and a little bit more clearly. The extra space in the amorphous solid allows it to be more flexible, because these particles can move into this empty space, whereas we don't see hardly any empty space here between the particles in a crystalline solid. In addition to that, the crystalline solid again has straight paths through for electricity and heat to move. So good conductivity with the crystalline solid, whereas with an amorphous, again, not a straight path through, slower movement of heat and electricity, not as conductive. These are the basic properties of crystalline and amorphous solids. Please see your notes or re-watch the video if you need any further assistance.